All right, so I'm going to talk you through this handout on parallel circuits. It can be found on the website. I should have handed it out to everybody. So here goes. A parallel circuit has at least one point where the circuit divides, creating more than one path for current. That's how we've differentiated between a series circuit and a parallel circuit. Each path is called a branch. The current through a branch is called branch current. If current flows into a branch in a circuit, the same amount of current must flow out again. This is a rule known as Kirchoff's current law, or just Kirchoff's law. So because each branch in a parallel circuit has its own path to the battery, the voltage across each branch is equal to the battery's voltage. If you know the resistance and voltage of a branch, you can do the calculation, or you can calculate the current with Ohm's law. We can say that current is going to equal voltage divided by resistance. That's all we're looking at. So let's do these. Let's do some problems here. Let's kind of jump right in. So here goes. So what is the voltage across each bulb? So that means if I were to measure this, if I used a voltmeter or a multimeter, you would find that it'd be 12 volts across here, and it'd be 12 volts across this here. 12 volts. Right? That's boom. Each branch gets 12 volts. So what is the current in each branch? Well, current is going to be 12 volts, right? We know that current is going to equal voltage divided by resistance. So here I have 12 volts divided by 2 ohms, which is going to be 6 amps of current. So I have 6 amps here, boom, and I have 6 amps here. So what is the total current? Well, total current is going to be 6 amps plus 6 amps, which are 12 amps total, boom. And you'll notice 12 amps here, 6 amps here, 6 amps picks back to these 6 amps here, and it's got 12 amps right here. So use the total current and the total voltage to calculate the total resistance. So I'll do this one here. Resistance total, so R sub T, is going to equal voltage divided by current. My total voltage is 12 volts, right? Boom. Divided by my total current of 12 amps tells me that my total resistance is 1 ohm. 1 ohm of total resistance. So let's keep moving on. We're going to do another problem. So use the parallel circuit pictured right to answer the following. What is the voltage across each bulb? Well, let's see. Same thing applies. 12 volts across this, 12 volts across this, 12 volts. What is the current in each branch? Well, each branch, we can solve for current. This is going to be voltage divided by resistance. 12 volts divided by, in this case here I have 3 ohms. 3 ohms here is going to be 4 amps. So I have 4 amps here, boom. And I have 4 amps here, boom. So my total current is going to be 8 amps. Oh, let me rewind here for a second. I don't know if I answered the total current up here. It's located right there, 12 amps. Okay, sorry, back to our problem here. So use the total current and total voltage to calculate the total resistance. So here I can do this. So resistance sub T for total is going to equal total voltage divided by my total current. So 12 volts divided by, in this case, 8 amps. Let me draw it in here. 8 amps total. So 12 volts divided by 8 amps is 1.5 ohms of total resistance. Right? Ohm's law. Everything comes back to Ohm's law. So use the parallel circuit pictured to the right. So bingo. Let's do this one. I'll mix it up. I'll use blue. Oh, excuse me. So what's the voltage across each resistor? Well, boom, 12 volts. 12 volts here, cha-ching. 12 volts here, cha-ching. There's only one resistor here, so it's just that value. So what's the current in each branch? Well, current is voltage divided by, 12 volts. Voltage divided by resistance. 12 volts divided by, in this case, 2 ohms is going to be 6 amps here. Bingo, 6 amps. And here it's going to be 12 volts divided by 3 ohms, which is only going to be 4 amps. So 4 amps here. Boom. So notice my total current is 10 amps. It's going to be 6 amps plus 4 amps equal 10 amps. Bingo. So what is the total current and total voltage? Or use the total to calculate the total resistance. So resistance total is going to equal total voltage of 12 volts divided by total current. So 12 volts divided by, 10 amps, which is going to be 1.2 ohms of total resistance. 1.2. Bingo. And last problem on this page here that we'll work from. So what is the voltage across each resistor here? voltage here is going to be 9 volts across each of them. Remember, there's only one resistor here. So essentially it's saying, what's your voltage drop? So what is the current in each branch? Well, 9 volts divided by 2 ohms. This one here is going to have 4.5 amps. 9 volts divided by 3 ohms is going to be 3 amps. And 9 volts divided by 1 ohm is going to be 9 amps. So the current in each branch is going to be labeled here. 4.5 amps from here to here, 3 amps from here to here, and 9 amps from here to here. So what is your total current? Well, I just add them up. 4.5 plus 3 plus 9 gives me a total of 16.5 amps of total current. Total. So 4.5 amps plus 3 amps plus 9 amps equals 16.5 amps of total current. But I do want to focus on something that's kind of additional to this. If I have 16 amps of total current leaving and returning, if this diverts 4.5 amps of current this direction down branch 1, my amount at this location between branches 1 and 2 is going to be 12 amps. And therefore, notice 12 amps here, it's going to divert 3 amps down branch 2, and it's going to have 9 left over. Keeps on traveling along its merry way. And when this 9 amps comes back and picks up these 3 amps here, it's going to have 12 amps here. So I can ask you all these questions. What is your total current? Total current, 16.5 amps. What is the amount of current between branches 1 and 2? Well, it's 12 amps. And lastly, the third branch gets 9 amps of current. Okay, so if we flip this over, I've got kind of a phase 2 here for you. And this is just another way to supplement what we've done so far of calculating total resistance. So here goes. See if I can teach somebody something for once. Finally. Here goes. In part D of problems 1, 2, and 3, you calculated the total resistance. We calculated. I did. We did. You did. Us. Me. We. He. She. Me. Tree. This required you to first find the current in each branch. Right? That's what we did. That's how we solved for total resistance. Right? We simply just did our calculations, and we calculated for resistance as voltage divided by current. And then we found the total current and used Ohm's law, right? This is what we did. We used Ohm's law to calculate the total resistance. But another way to find total resistance of 2 parallel resistors is to use the formula shown below. And I want to make sure, and we'll do some work with this, right? I'll zoom in on this here for a second. I want you to see here that we can actually take and do some calculations with it. And it's simply saying this. The total resistance here, total resistance is equal to resistance of branch 1 times resistance of branch 2 divided by the resistance of branch 1 plus the resistance of branch 2. So let's try this. Let me zoom back out and let's try this handout. Let's try this together. So if a circuit contains 2 6-ohm resistors in parallel, we're looking for the total resistance of the circuit. So our total equals 6 ohms times 6 ohms, which is 36, divided by 6 plus 6, which is 12. 36 divided by 12 is 3 ohms. Bingo. The total resistance is 3 ohms. So you're using this relationship of resistance total is equal to resistance of branch 1 times resistance of branch 2 divided by resistance of branch 1 plus resistance of branch 2. So 2 8-ohm resistors, I can take, and I'm just going to simplify this, I can just take 8 times 8 divided by 8 plus 8, which is 64 divided by 16, which is that's a 16, and that's a 4 ohms. 2 12-ohm resistors, so I can take 12 times 12 divided by 12 plus 12. I get 144 divided by 24, that's a plus, and that should be 6 ohms. A 4-ohm resistor and 8-ohm resistor, so 4 times 8 divided by 4 plus 8 equals 32 divided by 12, and that's what, 2.6 repeating? We'll call it 2.6 repeating. If I'm wrong, oh well, so forgive me. And then 12 times 3 divided by 12 plus 3. So here I get 36 over 15, and that's like what? 2 2/5, so 2.4 ohms, something like that. So let's do the 3 resistors, and this one will challenge you a little bit, but let's get this done. 3 8-ohm resistors. Well, I can only do 2 at a time. That's the key here. I can only do 2 at a time. So the bell's going to ring, so I'm going to pause here in just a second, but I'm going to keep showing you the work. So 3 8 ohm resistors. Here I have 8 times 8 over 8 plus 8, which is 64 over 16, which is 4. But that's only 2 of them. I still have another one. So I'm going to take 4 times 8 over 4 plus 8. So here I have 32 over 12. And I get, 24, 8, so 2.6 ohms, 2.6 repeating ohms total resistance. If I have 2 6 ohm resistors and a 2 ohm resistor, I can go 6 times 6 divided by 6 plus 6, which is 36 divided by 12, which is 3. And I need to multiply this times 2 divided by 3 plus 2, which is 6 divided by 5, which is 1.2 ohms for this one. And then last but not least, 1, 2, and 3. So 1 times 2 over 1 plus 2 is 2/3. So in this case here, I just did my total resistance between these two. So if I have 2/3 times 3 divided by 2/3 plus 3, you would find that this becomes 2 over 3.6 repeating. And 2 divided by 3.6 repeating is something like, I don't know, 1.2, so 1 point, I don't know. Let me make sure I put this number in here correctly, because I don't want to end on a bad or wrong number. So 2 divided by 3.6, 2 Oh, whoops, what am I doing? That's why I was confused. It should be 0.5 repeating, which we call 0.6 ohms. I hope that helped make sense of this handout.